Welcome to Talkin Shop with ShopSabre. My name is Brandon. I'm going to be the host of this podcast. And in this podcast, we're going to talk about all things related to CNC. We're going to dive into a variety of topics, discussions, tips, tricks, and collaborate with others in the industry, including professionals from our own organization. Hopefully you'll join us. We're going to have a lot of fun in this, but we're also going to hopefully teach you a few things related to the industry. So join us every week. We're going to have a new podcast. Check it out on all your favorite podcast host sites. And let's have a little fun talking about CNC. Welcome back to Talkin Shop with ShopSabre. I'm Brandon. We are back for episode 3. Jesse.
Can you believe it?
We made it.
We've arrived.
We've got here. So we're having a lot of fun.
We're famous at this point.
I don't know if we're famous, but I know the whole second grade knows about us.
That's for sure. My daughter shared it with her whole class. They wait for this to come out every week. I think they're the only ones listening to us.
It's because we're on the same level as them.
You're not kidding.
Yeah.
Same mentality as the second graders.
That's what we are. So here we go. But no, it's kind of cool. We've got a lot of good feedback. We appreciate everybody tuning in every week. We had actually a gentleman this week that reached out to me. He runs heavy equipment, and he said that he can listen to this while doing his job versus being able to watch YouTube videos. So shout out to him for watching this or
Goes
listening
back
to this.
to what we said, right? You can't operate heavy equipment and watch Router Bob.
Well, you might be able to, but again, you can only do it once.
Probably shouldn't.
Yeah, probably shouldn't do that. You can do anything once, though.
You listen to us two clowns instead.
Yeah, there we go. So today, we're going to kick off the subject of ball screw versus rack and pinion.
Awesome. I'm so glad you brought this topic up, Brandon. This is very important, especially when it comes to the overall movement of the machine and how important it is.
Exactly. And, a lot of people have asked us, it's always the, which one's better, ball screw or rack and pinion? And the reality is that ShopSabre, and I'm going to say ShopSabre because, hey, that's where we work. That's what we are here. So
yeah, you're on our podcast.
Yeah, you're going to hear a lot about ShopSabre today. But the reality is ball screw versus rack and pinion, there's not one answer. The technology exists because there's a right place for each one of them.
So this isn't a one-size-fits-all.
Correct.
Okay.
There's no way you can look somebody square in the eye and say, in every application, this is better. There's no way. That's why both of them exist. And, we're going to go through some of that today. We're going to talk about, let's start off with, what the hell is a ball screw?
What the hell is a ball screw?
Right? A ball screw realistically is a mechanical linear actuator that translates rotational motion to a linear motion with little friction.
You couldn't sound like you read that out of a dictionary more.
Well, I read it out of a dictionary, so that's
pretty good.
Yeah, well, thanks. My reading skills, I got
top
those
notch.
Second grade.
Shout out to you, Kinley.
So there we go. But yeah, so what is a ball screw really? Like you said, I gave you the definition, but really what is it? It's a threaded rod that has a raceway for ball bearings to travel through, and it's a precision built screw. Essentially what is it? It's a more precise, nut and screw, if you will. Really that's what it is. The advantage to it is it can take a lot of thrust. It takes a high thrust load, and that allows you to apply more cutting forces and allows you to do things that you just can't do with traditional ways of moving equipment. When you look at things like a ball screw, you start to find that it's more accurate, higher cutting forces, but it has some negative things as well. Really, what is the function of a ball screw? Namely, the screw is a mechanical element that converts rotational motion into a linear motion. In other words, it makes the machine move. And these screws that move things or transmit forces are done in a way that it actually takes small rotational forces and turns them into large thrust. Or in other words, it's force to push. It allows the machine itself to apply force through the cutter, in a heavier cutting, method. Where do you see a ball screw? What's some of the applications that you see a ball screw in?
In the world or on our machine here?
Yeah, I think in the world. Let's talk about that.
Wow, you see them on large equipment, right? You've seen them there. Larger mills run ball screws. Where else would you find a ball screw?
Yeah, so, a lot of times, let's go break it down onto the machine level. You're always going to see a ball screw in the Z-axis pretty much. Most industrial equipment is going to have a ball screw in the Z-axis. All your aerospace mills typically are going to be a ball screw. You're going to typically find that a lot of your milling centers are ball screw.
Yep.
And it kind of goes back to the applying a large amount of thrust, right? You want to be able to, with those type of equipment, you need to be able to cut things, in a very precise movement, but with a lot of force.
And a lot of speed.
Yeah, and that's the advantage is the ball screw creates, some of its pros is less friction and higher accuracy. That's really two pros. Now, I said there are some cons to it. Let's talk about those for a second.
Yeah.
The restriction on length is one that people need to take into consideration is really ball screws are best at when you're in a 12-foot run or less. When you get over 12 foot, you don't have some of the technology that you have in the smaller machines. So if you're going over 12 feet, yeah, there's going to be a time and place to consider using a rack and pinion system. Now, another thing is one of the cons to a ball screw is, let's be honest, it's expensive.
They're not cheap.
They're less availability. There's only a handful of people that you're going to buy a ball screw from in reality. There's a lot of technology you have to understand in a ball screw. So when people think of expenses, they think, oh, it's going to be expensive to repair. No, forget that. That's not what we're talking about here. It has nothing to do with repair expenses. I mean, don't get me wrong. A ball screw has more cost than a rack and pinion. I mean, that's part of the technology. But the reality is the expense is actually on the manufacturing side. When we build a machine for a ball screw, it has to be done with a higher level of accuracy because, let's be honest, a ball screw is going to bind if it's not aligned correctly, right?
Right.
So when you start looking at a ball screw, how do we do it? What do we do? When you look at a ball screw, we're doing it through the means of a more accurate build quality. And so, let's take a step back real quick. We'll get into that in a little bit here, but let's now talk about, rack and pinion.
What is a rack and pinion? Isn't that a car part?
Yeah, well, you know what? I think you're right. That
I
is
think
in your
it's next
car.
to your steering wheel, doesn't it?
Yeah, correct. You got your rack and pinion in your car. But, rack and pinion is a type of linear actuator that compromises a circular gear, the pinion, and then engages a linear gear, the rack, which operates to translate rotational motion into a linear motion. That was a mouthful there, wasn't it?
That's a lot of dictionary reading today.
Oh, God, I can't handle this. Too much dictionary. But let's be honest. What is that? So
Yeah, break that down for us.
Yeah, what's the purpose of a rack and pinion? A rack and pinion is the type of linear actuator that compromises circular gear, the pinion, and engages the linear gear, as I mentioned before. What that means is you're going to have a gear that rides in a track. As that gear turns, something moves. And generally that gear is attached to something like the gantry, and the gantry moves as that gear rotates. Now, that gear is actually chasing a track. That track is stationary mounted. It's on the side of the machine typically.
Right.
And those gears move up and down. Well, what's the pros to that? Well, it's pretty rigid. Let's be honest. The gear's not moving.
They're not going anywhere.
Yep, the gear is fixed to the side of the machine. The only moving part is that rotational actual gear itself. Yeah, the cog. And then another advantage to it is, your accuracy is not restricted by length. You're going to be able to run this as long as you want. Like I said, you can go 16, 20,
That's
30
where you get into longer tables.
Exactly. Let's be honest. Most of the machines that we deal with are under 12 foot.
Yeah.
So we don't have any real gain in that because it's not our market. That's not who we're really, catering to. So for us, it's not really a pro if we can't use it. And, on a cons thing, where's the con on a rack and pinion?
Lot more maintenance.
Yeah.
That's one of them.
Yeah, there's a lot more maintenance. It's more complicated to service. When you think about it, a gear's moving up and down that track, right?
Right.
Let's break it down to the y-axis of a machine. We call the y-axis our long axis. So the y-axis has twin gears, right? You have one on the left side, one on the right side. As that gear moves up and down, obviously the gear is changing up and down the machine, its tolerances, simply because, again, that track's not moving. The track is stationary. So as the teeth mesh, the areas that get the most wear are going to wear more. The most use are going to wear more.
Right, so if I'm cutting in the front of my table more, then I'm going to wear out the front of my table.
Exactly. And so when we say it's more complicated to service and more maintenance, is you have to adjust for that. You have to take into consideration where you've used the machine more. You have to adjust your gears.
So you're talking like making manual changes on your rack to compensate for that wear.
There's some of that, yeah, exactly. And some of it you might do it in software, you might do some things, but the other thing is too, that gear is exposed. That rack is exposed, right? Debris flying in the air, your dust or your metal chips, whatever you're cutting, can land on those tracks.
We're looking at premature wear then, right?
There you go.
You got
So
material stuck in your gears. You're wearing out your gears quicker.
Exactly. So again, more complicated to service because you got to clean that gear out. It's not something that's just maintenance free. And then the other con to rack and pinion that we should talk about is really the potential backlash. Gears have to have a degree of play or they can't turn.
You can't make half a turn.
Yeah. No. Exactly. And that the reality is you have to be able to put enough backlash in there where the machine can move freely. But not too much, because if you put too much in there, now you have play.
And that'll affect your accuracy, right?
Exactly. And so, as we break this down, really, where is that fine line? Where do we say, okay, we have enough backlash versus we have too much backlash? The reality is 3 to 5 thousandths. That's what most people will say on a rack and pinion system. You're going to see about 3 to 5 thousandths of play on any gear to maintain a smooth enough motion while not giving up too much accuracy. Well, the issue with that is backlash is a stackable number, meaning the more gears you have, the more backlash you also have because each gear is 3 to 5 thousandths. So if I have 4 gears on a machine, I have 3 to 5 thousandths times 4.
So you could be changing all over the table.
You could. And then, vice versa, it also subtracts. So as you start cutting things, if the gears are, reversed and you end up on certain parts of the area where it's actually canceling itself out, you might find zero backlash. And that's where the competitors are going to tell you, oh yeah, zero backlash, because they're not lying to you. The reality is you could have zero backlash in some areas. But what they forget to tell you is you also could have upwards of 20, right?
That's a lot.
Yeah, I mean, that's a lot when you start adding up numbers. The naked eye can see that. When you have 20 thousandths backlash, you're going to see that in a part.
Yeah, you're going to see that for sure.
And as we start diving into this a little more, let's talk a little bit about rack and pinion. Helical versus straight rack.
What's the difference?
Well, the difference is one's a little quieter and transmits a little bit more force. The helical rack and pinion generally is quieter, and it generally allows you to apply more cutting forces.
That's good.
Well, that's a great thing. Again, there's a reason why ball screws are helical. It applies more force. But in both cases, maintenance still must be considered, and helical does present, a higher wear point. It doesn't necessarily mean it's maintenance free. It just means you've applied more force. Well, like anything, if I apply more force, I've also applied more wear.
Correct.
And so as you wear the gear, you have to take into consideration more maintenance, more frequent.
Right, that's what it sounds like.
And so as you go through rack and pinion, people want to believe rack and pinion is a one-size-fits-all, and ShopSabre will prove it. It's not. We have rack and pinion on both of our plasma lines, our Shopmaster and our Sidekick plasma, so we're not going to say that we don't use it. And we also have it on our RC series, our recreational craft machine.
Yeah.
The reason we use rack and pinion in those environments is different, though. The reason we use it on a plasma is, the reality is, a plasma table, the accuracy is already limited by the flame.
Right.
The flame can only see so much tolerance, and so generally speaking, the flame tolerance is less than what the actual rack and pinion's tolerances are. So 3 to 5 thousandths is better than you're going to typically see with a flame. So as you start trying to, figure this whole thing out, where do I use rack and pinion? Well, plasma is a really common area. You see it on plasma because your flame is your limiting factor, not the machine, and you're going to be less worried about tight tolerances, more concerned with speed and, of course, affordability. Rack and pinion is typically going to be a cheaper way of building a machine. And so as you start looking at the rack and pinion on the router side, why would we use it on a router?
It's cheaper. It's cost effective.
Yeah, exactly. It's cost effective. And so as you look at ShopSabre's more affordable machine is a rack and pinion machine. The more expensive machines, which tend to be more accurate, those machines have ball screw. And so you kind of start looking at the levels of a machine. Let's be honest, nobody's charging you less for better technology.
I would like to see that.
Yeah,
I wouldn't mind.
Yeah, exactly. Nobody would mind it. But the reality is there's a reason why ball screws cost more money. The reason why you see them on more precise machines, there's a reason why you see them on more expensive machines like the mills and the aerospace centers. Those things require a tighter tolerance, and therefore tighter tolerances require more technology. And so the ball screws that you find in a CNC machine generally are going to give you a higher level of cutting forces and a better cut quality, simply because you have less backlash, for one,
right?
But you also have less vibration. Let's start looking into that a little bit. Competitors, let's just dive into it, right? Competitors say ball screws suck, right? They don't want a ball screw
because they don't offer them.
That's exactly it. And I'm glad you said it, because it's easy for a sales guy to simply say, you know what, the rack and pinion system is better. Well, the next question out of your mouth should be, well, can you sell me both rack and pinion and ball screw? If they can't say yes to that, if they truly don't have a product on their shelf that they can sell you that's ball screw, they're going to give you a biased answer.
Sounds biased.
Yeah, and when you look at ShopSabre, we have no reason to give you a biased answer. The reality is we can sell you a rack and pinion machine. In fact, the rack and pinion machine is cheaper, so that would typically make our team's jobs easier, because let's be honest, people want cheaper. So if I could sell you something cheaper, it makes our jobs easier.
All day.
So going back to it, we have no reason to push you from one to the other unless it's really for your gain and honestly our own gain long term, because we're going to give you that lifetime tech support. And if I don't have to work,
we got to stand behind this machine forever.
Exactly. And so if we don't have to work on it as much, it's a win for us. So less maintenance, less headaches. It's a win for ShopSabre, but that also sounds like a win to the customer too.
It's a huge win for the customer.
So let's look at it. Let's go back to, but the competitors say ball screws suck. Well, one thing you're going to hear a lot of people say is whip.
We don't have whip anymore.
Yeah, whip doesn't exist in our machines simply because we've got a technology we've developed in our machines called whip-free technology. And what we, super classy name there.
It is. It's pretty awesome.
Whip-free.
You get that out of the dictionary?
No, I did not. Whip-free. So What that means, though.
What is whip?
Yeah, so whip is, let's break it down in the real world. Let's look at a jump rope, right? If I hold onto a jump rope on one end, you hold onto the jump rope on the other end, and we start moving that jump rope back and forth, it's going to develop a whipping motion, correct?
Correct.
The faster we want to go, the larger the whip is going to be. On a ball screw, that's traditionally what whip is referred to. It's a fixed mounted screw, a fixed mounted nut, to the gantry in a rotational screw. So the screw has a motor attached to the end of it.
So your screw rotates.
Yep, and you spin that screw as fast as you can. And obviously the faster you spin it, the faster the machine moves.
The more it's going to want to whip around,
exactly,
right?
and the more it whips outward. The center is not supported. It can't be supported because that ball nut has to go back and forth. So that's what causes the screw to whip out. Well, the downfall of that is so you either have to go slower to prevent whip.
We don't want to do that.
Nope, that's not ideal, not in CNC machining. Or you have to come up with a massive ball screw for one. I mean, if you're going to have no whip and rotate a screw, your ball screw needs to be absolutely ginormous.
That sounds really expensive.
That sounds very expensive and not practical. So what you do is then you go to a rack and pinion system. I mean, that's really what you do to get rid of that.
Right.
Or you could just come up with a new technology. And the new technology today is what ShopSabre uses.
The fixed ball screw?
The fixed ball screw. There you go. You beat me to it. The fixed ball screw, what it does is it takes the ball screw and actually holds it tight on both ends. And then, you know what? To be honest with you, the ball screw may droop a little bit in the middle, and it doesn't matter. You know why it doesn't matter? Because you have a linear guide system. Every machine is equipped with linear guide rails. And so as that machine moves down the linear guide rail, it's a set number. It's a set accuracy. So as the ball screw is being used in that area, it's pulling the ball screw by connection to the gantry into position. So the gantry is actually aligning the ball screw as it moves. So therefore you have less concerns with whip because the ball screw is not spinning. The ball screw is stationary.
So even if it does sag in the middle, the machine's going to pull it back up to where it needs to be.
Exactly. And so what that means is as the ball screw turns, or as the ball screw doesn't turn in this instance, the screw is actually moving into position with the rotational ball nut. The nut itself is hollow. So it has a hole through the center, and the screw runs right down the middle of the nut. And then the nut attaches to the gantry, and the motor attaches to that. So as the machine moves up and down, the ball screw stays stationary, therefore no whip, and all you're doing is spinning that nut faster or slower based on speed. This was developed for high-speed machining. This was something that has been developed. It's been out for a while, but let's just say the last 10 years or so is what ShopSabre has utilized it quite a bit because you've seen a lot more of it. It's made ball screw, more affordable, but more practical as well because now you can achieve the machining speeds that you need to achieve. And, a lot of these companies out there, they advertise 3,000 inches a minute or 4,000 inches a minute or 2,500 inches a minute, and they try to say, look how much faster we are. Jesse, when's the last time you ever cut something at 2,500 inches a minute?
That's not happening. Very, very rare.
Yeah, it's pretty unlikely that anybody listening here is realistically cutting at those speeds on a day-to-day basis. Some of you guys might be, and some of you are laughing at me right now saying, oh, I do it, right? The reality is there's far less of those people in the world. I mean, in all the years of me doing this, our fastest machine is 2,100 inches a minute, and I have, to this day, not come across any application that I've ever attempted where I was like, man, we need more speed than that. It's just not possible. I don't cut things at 2,100 inches a minute. The bits don't allow for it. The material hold down doesn't allow for it on certain parts. There's limitations to what the material will even let you move through it at.
In reality, when you're getting that fast, you're shaving off seconds, right? You're not taking off full minutes because we're already doing it in minutes. Yep. So what are you really gaining?
Exactly. And that's the reality is most of these machines are sitting idle for part of the day. You're not running them 24 hours a day, 7 days a week. Most people don't have the demand for it. Can the machine do it?
Oh, all day.
But most people don't have the work to do it. The machines are doing things. Let's break it down. Again, when you look at a ShopSabre, we've got customers that are running cabinet parts. Let's just start there. Cabinet parts. What takes the guy a day to do, the machine does in like an hour. The reality is we can cut, a lot of parts, realistically, a full sheet of material, call your base cabinet, cut, dadoed, drilled, the whole works in 5 to 7 minutes consistently.
It's an efficient machine. I had a customer recently just call me, and he thought it was funny when he ordered his machine. He said, there's no way this machine is going to outwork me. It is not going to be faster than me. He's already looking at a second machine. He's going to upgrade from a 23 to a Pro.
Yep.
It's time.
Yep, and that's exactly it. I mean, when you start looking at CNC technology, it makes things more efficient. It allows you to do things that you couldn't do before. And a lot of businesses don't realize with the same amount of manpower that they had before, they can double, triple, sometimes quadruple their production output because the machine cuts so much time out of the process.
It's efficient.
It's very efficient. And so how do we achieve that? Well, we do that through drive technology. And so again, getting back to the topic, let's take ShopSabre out of the equation here, but let's just talk about ball screw versus rack and pinion and the technology itself. What are you really getting? Well, with the ball screw, you're getting ball bearings. With rack and pinion, you're getting gears. Well, just break down the science of those two things. A ball bearing, by nature, is one of the most accurate technologies out there. A gear, by nature, is very durable, but it does have less accuracy. I mean, it has points. And every point that you have is a possibility for a degree of change. A point isn't going to stay a point forever. As that point rounds over a little bit, your accuracy changes a little bit. And so every time your machine moves up and down, every time, it's wearing off a little bit of the pinion, right? Or a little bit of the gear.
Right.
And therefore, over time, you're going to have to replace gears. You're going to have to change things. But now take into consideration, you have two gears on that y-axis. Your left gear is going to wear different than your right gear. There's just no way about it. It's going to happen.
So would you have to replace both sides at the same time then?
Ideally, you want to replace them both. You want to replace them at the same time so you stay very consistent. But the point is will a rack and pinion machine cut parts? Absolutely. And will you get good cuts from it? Absolutely. You can get good cuts from a rack and pinion machine, but it won't be as consistent and it will not be for as long. A lot of people find that in 2 to 3 years, you are replacing parts or sometimes a machine on rack and pinion because of wear.
I don't want to do that.
No, it's not fun to install a machine and then have to uninstall it or take your machine out of service to actually do these repairs and making sure you get it right or paying somebody to come out and do it. The reality is that's why people, I kind of chuckle when people say, well, rack and pinion's cheaper. It is cheaper. There's a reason why it's cheaper. It's going to cost you more in the long run. It's cheaper up front because there's less technology. But long term, you add up the cost of maintenance and some of the stuff that goes into this, and you're not saving as much money as you think you are.
Right. I got a really good quote this week. A customer told me that he was between an RC and a pro, and his father gave him this advice. He said, it takes a very rich man to buy a cheap machine. That stuck with me. I like that's powerful. He said, you got to have a lot of money to continue to fix those and do the maintenance as things wear out and break down.
And that's really true. I'm glad you shared that because, I hope that resonated with some viewers here because the reality is ball screw machines are not more expensive long term. Yeah, okay, is the price tag up front a little bit more money? Yes. But what are you getting for that money? Well, you're getting a machine that's generally going to last 3 to 4 times longer. So does it really cost you more money? Well, no, because the typical ball screw machine is a minimum of 10 years. I mean, I know we have machines that were built by my father 21 years ago, still in the field running today.
That's incredible. That's incredible.
And that's the advantage to a ball screw machine is that they last a long time. I mean, the used market for a ball screw is very good. The resale value is very good. When you start looking at rack and pinion machines, they don't hold their value as long. The value falls off a lot faster because, again, as they get worn, they're less accurate, they're less dependable.
Right.
But also, they require more maintenance long term. I mean, even if they are dependable and running okay, you're still going to have a situation where when do you need to replace the gears? Well, somebody has to figure that out. Whether it's in a poor cut quality you figure it out or the regular maintenance you're doing, at some point, you have to be a little bit more talented with a rack and pinion machine to get the performance. Can you get a performance out of a rack and pinion? Absolutely. But you're going to do it through the means of technology. So whether you do that in a software analysis, let's say you do backlash compensation, right? My favorite is I hear these machine manufacturers that sell for comparable prices to what we sell for, and sometimes a little bit cheaper than us. And they'll say, well, look at some of the big machines. They run rack and pinion just like us. That's not entirely true. That's a heck of a marketing job. Yeah, heck of a marketing job because the reality is the bigger machines, the biggest machines out there run ball screw, to be clear. They're just pointing you towards the ones that look like them. But if you look at the most expensive machines out there, they're ball screw.
Yeah.
And when you start looking at the rack and pinion that a $100,000 machine uses versus the rack and pinion that a $40,000 machine uses, you're going to get a very different answer.
Well, it's different technology, isn't it?
It is. It really is because, for one, the rack and pinion system, you have precision ground rack in some cases you don't. Rack and pinion, helical, some people are using, a twin gear solution. Some people are using split gears, pinions, things like that. There's some technology in there that you have to take into consideration, but also go back to the machine itself. You have to start looking at some of the technology that's used in the frames and the technology there, the milling of the frames, but also start looking at the controller. You have to start looking at a controller when you get into rack and pinion. If you want a very accurate machine with rack and pinion, you have to have a controller that has backlash compensation in it. You have to have something that has the ability to say, okay, I've moved this much distance, but the backlash is this, so we need to subtract that so we're in the right accuracy.
So it makes adjustments for you on the fly.
It does. And
Okay.
so you're talking about a controller that a lot of times is 40 grand by itself. How are you going to buy a $40,000 machine with a $40,000 controller on?
That's a lot more money than buying ball screw.
Yeah, that's exactly it. So when you start looking at it, you end up with a machine that is $100,000 plus. And yeah, the controller does a little bit more behind the scenes to try to give you the accuracy that you would need. The reality is, you could just go buy a ball screw machine. The ShopSabre machine specifically has ball screws on the X and the Y and the Z, and it's going to cost you a fraction of the money. You know, when you start looking at the cost, you're investing less money up front because it's not $100,000, but you also have all the benefit. You have the added accuracy of the ball bearings. And so long term, your maintenance is a little bit less, your performance is a little bit more, and really what you're gaining with this machine is overall cut quality, but life of ownership. Your money is going to be returned to you over the life of ownership.
Well, like you just said, some of the machines your dad first built are over 20 years old. They're still out in the field working today. I mean, to get 20 years out of a ShopSabre, it's pretty awesome.
It is, you know, and that's really what we're going for. We're going for a machine that's going to last you a lot longer. And, you know, when you look at a ball screw machine, there's a lot of things, you know, life expectancy, as we mentioned, expenses, the whip, you know, all these things that you hear about, they really break it down by the technology again. Let's go back, look at all these machines. Rack and pinion versus ball screw. When you look at a rack and pinion machine, it still has linear guide rails on it, does it not, Jesse?
Yes, it does.
Every linear guide bearing has what inside it?
Bearings.
Yeah, and they're ball bearings, just like the ball screw. So when you start looking at a linear guide motion, you have a rack and pinion machine with linear guide rails on it that's literally using the technology that a ball screw has. Why would you not expect the same technology in your drive system, right? When you start getting into precision motion, I would expect ball bearings everywhere if we're going to use it part of the way, right?
Right.
And what other axis? I mean, when you start breaking it down, you know, where else do you find ball bearings in a machine? I mean,
You got your Z axis, your X axis, your Y axis.
yep. So all of our machines have the, like you said, the Z, the X, the Y, but and all of our competition generally in this price range, you have ball bearings in linear guide system. You have it in the Z axis. So it's good enough to use in those axes, but it's not in the X and the Y. It doesn't exactly add up. When you start looking at these machines, the most accurate axis on the entire machine is the Z axis.
Right.
If the machine doesn't cut to the right depth, your parts aren't any good. If the machine can't perform a 3D motion, parts aren't any good.
Right.
So if I can't change tools and it be accurate when it changes tools,
What's the point?
yeah. So you start looking at this like tool changing, you know, tool touch off. You start looking at the drilling of holes. You start looking at pocketing. You start looking at some of these things. All of that stuff is dependent on your Z axis. Your Z axis is using a ball screw.
Why wouldn't you use ball screw on the other axis then?
Exactly. It doesn't make any sense. And everybody goes back to the reason they don't use it is because of whip. Well, just use the newest technology. You don't have whip. Whip's not an issue then. Like,
Right.
It doesn't translate into a problem. So when you start looking at ball screws, you really start looking at the technology. Don't look at the company. Don't worry about what any sales guy says. Don't worry about, heck, don't listen to what Jesse says half the time. Doesn't
Yeah,
matter,
don't,
right?
definitely don't listen to me.
Doesn't matter. I mean, you know, in all seriousness, what Jesse says doesn't matter. It's what he's giving you for information. Where's the facts coming from? Well, ball screws versus rack and pinion. Let's just break it down by technology. There is a level of rack and pinion that you can buy that you will get good cuts with. I'm not going to deny that. But you're going to spend $100 grand to do that.
I don't want to do that.
Yeah, you're not going to get it in this price range. The reality is, if you're price sensitive, if you're looking at something and you're trying to get into a machine at the sub $100,000 price range, there's no rack and pinion machine out there that's using a backlash compensated controller with the level of rack and pinion you need to. It's just simply not doing it. That's why they're under $100,000.
Makes sense.
And, you know, that same goes for us. I'm not going to deny. ShopSabre, we're the same way. We do not use the backlash compensated controller on our under $100,000 machines, and we definitely don't use the rack and pinion at the level that you would have to use at a $100,000 machine. We can't do it and sell you a machine at that price range.
It'd be unaffordable.
Exactly. I'm not going to sit here and tell you that I can. So the reality is that's why we have a ball screw solution. You know, when you start looking at it, you start looking at, you know, a ball screw. Let's break it down a little bit here, a little bit further. How do we get more forces out of a ball screw? Well, one thing you're going to get here is you're going to have more contact surface. A ball screw by nature is going to generally have somewhere between 5 and 7 inches of contact surface.
That's a lot of contact.
Yeah, especially when you consider that the typical rack and pinion machine is going to have about an inch worth of contact on a gear at any given time. So it's
That doesn't seem like enough.
no, it's 5 to 7 times more contact from a ball screw machine. Well, now if I have to take a bit and push it through a piece of material, having 5 to 7 times more surface area contact is more stability. let's step back. Let's look at a football player, right?
Yeah.
Football. You're a football guy, right?
Yes, I was.
You're a football guy. What were you?
Defensive end.
There we go. So
Go
as a
figure,
defensive,
right?
yeah, as a
The
defensive
size for it.
as a defensive end, if you put your feet together and try to attack that lineman, how's that going to work?
It's not. You're going to tip me right over.
Yeah, that lineman's going to set the edge, no problem there, right?
Right.
But if you widen your stance a little bit, right? Mm-hmm. And now you push against that, that other lineman that you're up against, you probably have a pretty good chance at least holding your ground or overpowering them.
Usually it was overpowering.
Okay, so as you look at that, that's because of the wider stance, right? When you look at a ball screw, it's the same thing. Widen the stance, apply more pressure, right?
So you get more cutting forces.
You get more cutting forces. You get less vibration because of the fact that you are widening the stance.
And vibration is really important, right?
Exactly. And so a lot of people think like, well, I can overcome vibration multiple different ways. You can. You can throw a bunch of weight at something too. That's another way to do it. But weight costs money too. So how can we do it without cutting corners, but without raising the price? Well, you have to start using better technology. And so by putting a ball screw on the machine, I've increased my cutting forces, I've increased my accuracy, and yeah, I've increased my cost a little bit on the front end. But on the back end, I've reduced my maintenance, I've reduced my overall cost long term,
Right.
and I've reduced the headaches. I mean, the reality is I don't have to do as much maintenance on a ball screw. A ball screw has a sealed nut with a bunch of ball bearings inside it, and that ball screw itself is self-lubricating, and it contains, an oil bath, if you will, for those ball bearings. And so you have less clean out. You're not cleaning out each individual ball bearing, where with a rack and pinion, you have to clean out that gear track.
Which takes time. And let's talk about that time. Like, who has the time to do maintenance on this thing all the time? I want to keep cutting.
Exactly. And that's exactly it. You don't have the time to stop production to work on that. You don't have time to think about it. Your guys don't have the time for it. And let's be honest, some of your guys you don't want doing it, right?
Right.
Yeah, let's be honest.
You don't want me doing it.
We don't want Jesse
I'm
doing
the
it.
very last person.
That's exactly it. And so, talk about truth bombs here, right? The truth is, ball screw is more accurate. Yeah, ball screw does cost a little bit more, but ball screw is going to be an overall better return on your investment. And so, ball screw versus rack and pinion, when you're looking at a router, ball screw is by far a better technology when you look at the facts.
Brandon, let's talk about a couple applications where rack and pinion makes sense.
That's a great idea. I'm glad you're doing that because I don't want to sound like, the one-stop shop is ball screw, because there are certain areas where ball screw does not make sense. And, if we're not worried about accuracy, if we're really not worried about production, right? We're not worried about doing something.
Or speed.
Yeah, long term. Our cut forces don't need to be as high, whatever those situations are. Rack and pinion is great. I mean, there is an entry level. Let's be honest. If you're going to go buy a machine from China, right?
Right.
You're going to buy a machine from China, 99% of them are going to come with rack and pinion.
Yep.
Let's buy a rack and pinion machine from America.
Goes back to what we said last week.
Yeah, it goes back to last week's topic, right? I mean, that's an area where I would say rack and pinions are a great solution, is that if you need to keep your costs down, and the choice is either I buy this American machine or I buy this Chinese machine, well, I'd say you're probably better to give up a little bit of technology than all of the technology. I mean,
Right.
Going to a Chinese machine or something like that, you end up putting yourself in a situation where you're giving up more than you're gaining at that point. So let's end up with an American machine with rack and pinion, and you're still going to have the service and all the other great things that come along with American made, but you don't have as much accuracy per se, or you don't have the long term, like maybe this is your stepping stone and you are going to buy a new machine in 2 years and you already are committed to that. That maybe is the direction you go. But let's also talk about an application where maybe just less accuracy, right?
Yeah.
Some less accuracy situations would be, let's say we're cutting with a flame, right?
Right.
That's one area. Let's talk about plasma for a moment. And we'll get into plasma next week. I know that's going to be a big topic, is plasma, but that's an area where you'll find rack and pinion a lot of. And the reason for it is you're dealing with debris from a metal shop. Let's be honest.
Right.
Nobody's eating off the floor at a metal shop.
Maybe.
Okay, I guess you might
It
be.
depends.
Yeah. I guess if you dropped that powdered donut on the ground, you're probably eating it, aren't you?
I'm picking that up.
Yeah, I knew you were. But the reality is, you don't want, the high accuracy items in some of those environments. The exposed to the elements, if you will. Rack and pinion is probably a better solution there. You're going to clean it out all the time anyways.
Right.
You really need to. Or the accuracy tolerances just aren't there. Flame cutting. Again, your flame is your limitation, not the machine at that point.
Right.
So there are some applications where rack and pinion makes sense. But let's go back and look at ball screw versus rack and pinion in the way of, what do you get out of a ball screw? What do you get out of a rack and pinion in terms of the other components related to the machine? Well, in a rack and pinion machine, the advantage to cost is really the fact that not just the machine being cheaper because of rack and pinion, but it's cheaper because of the other components that go alongside with rack and pinion. You don't need as much technology in the frames, right? I mean, let's be honest. The frame can be a little bit less accurate because, again,
You're working with less accurate technology.
exactly. So, I don't have to put as much into the frame. I don't have to, necessarily aerospace the frame when you're dealing with rack and pinion. You know, the reason for it is the track is setting the accuracy. The track is bolted to the steel, and even if it's not 100% flat on that steel, the gear has some slop already. The gear can, whether it's in or out, a quarter of an inch even some cases, right? For some machines,
Right.
You're never going to see it.
So you're only going to be so accurate.
Correct. I mean, the reality is, as long as the gear is making contact, it's making contact, and it's turning the gear. So you don't have to have as accurate of a frame, for one. So that's some area I've saved, right?
Yeah, less cost there.
Yep, less cost there. Generally speaking, I'm not putting as much cut forces in, so I probably don't need as heavy of a gantry.
Right.
So again, less cost there.
Right.
I can get away with some lighter weight materials.
What about motors? Do you need to have the same motors on on a rack and pinion machine?
Yeah, so the RC, and I know you
RC.
said RC a little bit there, so let's just jump on that. Yeah, you're right. The RC does not have the torque level that the Pro or the IS would have from ShopSabre, but in any rack and pinion machine, you're going to lose torque with the motors because generally, again, rack and pinion can't take the added torque anyways. So if I add a bunch of torque to something and I can't, let's put it this way. The Dodge Viper, right?
Sweet
car, right? Everybody thinks, when the Dodge Viper came out, that was the car, right? It was awesome. People loved it. But remember all those stories of people crashing Dodge Vipers?
Yeah, it seemed like it was every week in the news, constantly.
Yeah, people crashed. I mean, I think they said at one point, wasn't it like the most crashed car when leaving the dealership lot or something like that?
I believe so.
Yeah, don't quote us on that. We're kind of off the cuff there, but I believe that's what I remember reading on that. And
It sounds right.
yeah, I think so. But the reason for that was they had these super giant motors and no traction, right? All this torque, no traction, jump on the throttle, spin the car out, back it into the guardrail, and look super cool as everybody drove by in your, Viper, right?
I could see you doing that, though.
Hey, whoa. But the reality is here, that's kind of what you get with rack and pinion. You have the ability to only create so much traction, if you will, or only so much, actual contact. And so if you apply too much torque, you're going to spin a gear, right? You're going to jump a tooth. You're going to miss a step.
You bind up?
Yeah, you're gonna have some issues there. And so you have to take into consideration, you can get away with smaller motors on a rack and pinion system. Well, another thing you can do with a rack and pinion system, let's say I want to go that 3,000 inches a minute. I can gear reduction, right? I can use gear reduction on that. So I can put a big pulley on there, or I can put a planetary gear with a, let's say, 10-to-1 gear ratio, right?
Wow.
Sounds awesome.
Sounds
10-to-1,
incredible.
right? 10 turns, or one turn of the motor turns 10 turns on the rack and pinion, right? You're moving, right? You're going places.
Cruising.
Yep. You're going to have a lot of speed there, but you don't have as much accuracy because, again, you lose accuracy. The taller that ratio, the worse your accuracy is. So 10-to-1, you can't make the fine movements as much, but again, you're using rack and pinion. It doesn't necessarily matter, right?
Right.
So you give up in some areas where you gain in other areas, right? I saved a little bit of money. I can advertise I have these really fast machines. So in the underground world of CNC racing,
I've never heard of this.
I didn't know it existed either, but it seems to be. I mean, it seems like every sales guy out there that I've ever talked to knows about it, except for me. Because
I got really excited.
I know everybody's like, "Oh, our machine goes 3,000 inches per minute. Sweet. Are you going to take that down to the underground world of racing? Because nobody makes money racing their machine around in the air. Last time I checked, we're not racing for pinks.
Oh, I can't even take you serious right now.
Yeah, well, that's kind of how I feel about it. So that's why you don't hear ShopSabre really bragging on the whole speed thing. Like, yeah, we can go 2,100 inches a minute. It matters to a point, but what am I cutting at?
Right.
That's the number you need to look at. When you look at a lot of these rack and pinion versus ball screw conversations, rack and pinion generally is a lower number of cut speed compared to their transitional speed. So when you look at rapid movement speeds, that's what everybody advertises.
Right. Rapid. How fast it run around.
How fast can I go? But when you read in the fine print, in most of the cases, you're seeing these rapid speeds like almost 2 times faster than what their actual cut speeds are. Why can I go so fast when I'm not doing anything?
Why does that benefit you?
It doesn't. And that's the thing is guys think like, oh, I saved so much time between cuts. Okay, so add up how much time you actually save. You've saved seconds, not minutes.
Seconds.
Yeah, so you spend a lot, you save a little bit of money, but you end up in a situation where you save a little bit, but you give up a lot. You give up accuracy. You give up really speed performance when cutting, when it matters. And you start looking at some areas where they can cut corners.
This sounds like a lot more work on the back end on a rack and pinion machine.
Exactly. And so, rack and pinion versus ball screw, this is a little bit of pro ball screw. Let's be honest. You've heard a lot of pro ball screw today, but it's because I'm pro what works. I'm really pro on technology. You're buying a CNC machine because you're trying to incorporate new technology. Well, let's incorporate it fully. Let's do everything we can. Let's buy an American machine with ball screws, and you've gone the whole way, right?
You're there.
You didn't cut any corners there.
You've arrived.
Yep. And so ball screw makes sense in a lot of high tolerance applications, high cutting force applications. Rack and pinion makes sense in more budget-friendly applications or situations where you simply just don't need the tolerances.
Right.
Let's be honest. If you're cutting something that, isn't going to be measured, to a tolerance level, you could probably get away with it, right?
Right.
But when you start looking at cabinet parts, that's one area. Let's talk about cabinets for a second here. Guys are like, I'm dealing with wood. The wood changes, right?
Right.
Yeah, but you still have to have a finish, right? You have that edge finish is what people look at. Maybe you're using an edge bander. Let's touch on that real quick. Edge banders. Edge banders don't like to stick, to an unfinished surface. A surface that is a little bit rough.
Right.
So then you go out and spend this money on an edge bander. So yeah, you save your money on your CNC, and then you end up buying this expensive edge bander because now you need to have a pre-mill on it.
Well, that sounds like you're just shooting yourself in the foot.
Yeah, so I took my money from my CNC, put it into my edge bander, and I ended up the same outcome. Or
Right.
just spend a little bit more money on the CNC machine. You can buy the edge bander without the pre-mill in most cases. Now you save the money on the edge bander. So you save the money somewhere. That's one way to do it, is move the money to an area where the edge bander can be a little bit more affordable, but you still get the same quality, of cutting that you would expect. Whether you're getting into live edge, whether you start getting into architectural millwork. There's so many different things you can do with these machines, and you get a better cut quality. When you start looking at aluminum applications or plastic applications, having a ball screw system gives you a smoother cut. It gives you a smoother movement. And so it translates into edge finish. You will end up with a better performance in most applications. And with the right speeds, feeds, tooling, hold down, things like that, you really can't beat a ball screw head-to-head with a rack and pinion. I mean, you're just not going to do it unless you spend a bunch more money.
A lot more money.
Yeah, a bunch more money.
Oh, yeah.
A bunch more money.
Bunch more money.
Yeah, I don't know what happened there. But the reality is, when you look at it, the value in a ball screw is really the long-term play. It's the long game. Yeah, you might beat me on hole 1, right?
Right.
But my game is the long game, right? By the end of 18 holes.
You're going to be on hole 8 changing out your rack.
Correct, yep. And I'm going to be sitting in the clubhouse.
Hey, good shot.
It's about time.
Hey, it is about time. I mean, I just couldn't get the ball in the hole. I wanted to, but I just couldn't do it.
So we're going to finish faster here because we didn't have to do as much work. We're going to have the ability to get more done in less time simply because my machine can run faster.
Right.
We have a story that I always like to tell. I have a customer of mine owned a competitor's machine, and the competitor's machine happened to be a rack and pinion machine.
Okay.
And he jokes that he has both machines running in a shop, the ShopSabre and this competitor's machine. And to this day, he still uses it. But he starts the competitor's machine first every day. He said, Brandon, I always go in and I start that machine first. And the reason why he does that is because he said that he sets it up, he hits run, walks over to the ShopSabre, sets it up with the same job, same exact program, hits run, and the ShopSabre will finish first every time.
That's incredible.
So he's like, I might as well get the other machine started first because I know it's going to take longer.
It needs a head start.
It needs a head start, exactly. So the reality is the ShopSabre can complete the job faster, and it's not because we have this magical power, right? There's nothing special there. We just engineered it correctly. I mean, we've done things that our competitors just simply don't do. And, in a future episode, we'll talk about engineering and some of that stuff. But really today was ball screw versus rack and pinion. And when you start looking at ball screw versus rack and pinion, you start looking at the differences in really the difference in technology. Let's start there. Go back to that. Really, what are you talking about? When you ask me which is better, ball screw versus rack and pinion, my answer back to you is which one has more technology.
Right.
That's the answer that I will give you every time, because ball screws themselves have ball bearings. I mean, anybody out there who wants to talk about that can talk about it. But ball bearings, it's a better technology than a gear. I mean,
It's just proven. It's a fact.
It's a proven fact. Exactly. I don't need to make that up, because if gears were better, we'd all be using gear drive systems on the motion side. We wouldn't be using linear guide bearings. We wouldn't be using ball bearings.
Well, why would we use more expensive technology
Yeah.
if we could do it with less expensive technology?
Exactly. Why would we spend more than we have to if that doesn't make sense? But also, why would everybody's Z-axis not be rack and pinion?
It just baffles me.
I mean, to me, that's where your answers come from, is where is people using ball bearings? They're using it in the most critical axis, the Z-axis, and they're using it on that linear guideway. Like I said before, you get more for your money In long term, your play is going to be less maintenance, less costs. So really breaking it down, the pros of rack and pinion is really rigidity and accuracy not being restricted by length. Your accuracy is consistent. I mean, it's 3 to 5 thousandths over the entire whatever you come up with, until you factor in wear.
Right.
With a ball screw, the pros are less friction, higher accuracy, right?
Right.
The cons to a ball screw, it restricted by length. You can't go as far. Really, 12 foot's about as maximum you're going to go before you start running into some concerns there. And honestly, one of the cons is ball screws are going to cost you a little bit more money. So at the end of the day, what do I get for my money? I get better technology. If I don't have the money for it, what can I get? Get a rack and pinion system.
Get a rack and pinion
rack and pinion is a good solution for an entry-level budget, but be prepared. With a rack and pinion system, be prepared. You're going to have some long-term expenses. You're going to be replacing gears. You're going to be replacing rack. Just this week I had a customer call up and order some rack for his machine. I mean, he was just expected. It was one of those things where there was no argument on. He goes, "Yep, I know it's time to replace the rack."
Part of your maintenance.
He knows it, and it costs him money to do it. The other thing that you have to take into consideration is the backlash. Like I said, you got to think about that. Is the backlash livable? Can I live with the backlash? If you can, rack and pinion may work just fine for it. Over a 10-foot machine, my example always goes back to, a 10-foot machine, you're probably not cutting 10 foot long every time. On a 5 foot wide machine, you're not cutting 5 foot wide every time. Maybe you stick a 4x4 piece up there. Maybe you stick a 4x8 sheet up there.
Yep.
You're going to work at certain areas of the table more. Naturally, if you're anything like Jesse and myself, you're lazy. So
For sure.
You definitely don't want to walk to 10 foot if you don't have to. So you're setting everything at the front of the table.
Well, that's what I was thinking here. You keep talking about these longer tables. I don't want to walk 15 feet of table.
Yeah, me neither. Can I get one of those segways, you think?
That'd be sweet.
Segway to the end of the table, right?
Just segueing your maintenance on your machine.
Oh, maybe we should develop the ShopSabre Segway attachment. You can just segue down to the tool changer.
You should write that down.
The Segway, ShopSabre Segway attachment. Got it. So that might be coming up, but in all seriousness here, you have to think about where you are on the machine, what you're going to do with the machine. There's a right and a wrong time for rack and pinion. The right time for rack and pinion, budget friendly, less accurate. The wrong time for rack and pinion is high accuracy, high cut forces.
Right.
Simple as that.
Right.
When you start looking at rack and pinion ball screw, you're going to read a bunch of stuff on the internet. You're going to hear a lot of people talking about it. Start listening to what people are saying in terms of the technology. How are they showing you the technology? Are they talking about real world scenarios? Like we talked about, start applying forces, start applying accuracy, start looking at really what people are doing. Don't necessarily just take the words that are coming out of the sales guy's mouth. When the guy says, well, we're using the same thing as the rack and pinion machines at $100,000. No, they're not.
That's sketchy.
Because the next question out of your mouth should be, well, why aren't you $100,000?
Right.
That should be the next thing you ask. And you know what? I always tell everybody, there's a reason why some ball screw machines are $150,000. They have controllers on it that we're not running. They have, even with a ball screw machine, you can have a backlash compensated controller that reads all the time in real time, and you can get into some crazy accuracies. Our customers aren't cutting at those accuracies. We tell everybody these are not mills. These are routers. If you're measuring to mill tolerances, you need to buy a mill. You're not buying a ShopSabre. And that goes back to us selling you the right piece of equipment.
Right.
We're not here to lie to you. We're not going to manipulate you and tell you you have to buy a ShopSabre or you're never going to hold tolerances. You can hold tolerances with a lot of machines. You just have to work harder at it with some other machines. With the ShopSabre, you generally are going to work a little bit less hard, which
It's perfect.
that's a good thing for me.
That's where I want to be.
Yeah, same here. But the other thing is you have to have a less talented operator. Let's talk about that for a second.
That's a huge part of the equation.
Yeah, a ball screw machine requires less from your operator. Your employee can be, you can take anybody off your floor and teach them how to run a ShopSabre. With some of these, $100,000 machines, they're running controllers because of those compensations and some of the stuff. They're complicated. They're a school in themselves.
I can't imagine that's easy.
No, you have to hire a mill operator. You have to hire a guy who's been trained to do that.
That sounds expensive too.
That sounds expensive too. Exactly. There's mill operators out there, and some of you guys who are listening are mill operators, and you know what? Bless you guys. You guys are intelligent people, and you know the language and you know how to do it. But let's be honest, not everybody can afford you. That's the reality. Is not every mom and pop shop or starter or guy getting into this can afford that guy right away. But you got to get your hands on the technology. And so, again, there's a time and a place. We talked about it last week. There's going to be a time and place for a $150,000 or a $250,000 machine. The majority of companies that we deal with don't need that.
No,
they
they
can buy 2 or 3 of these machines, produce the same level of production, and still be cheaper.
We're very competitive when it comes to that. That's for sure. We compete with those bigger machines.
Yeah. So, as we break it down, I know we've talked about a lot today. Hopefully, everybody's still listening here. Hopefully I didn't put you to sleep with some of this ball screw versus rack and pinion talk. But I really wanted to get out there. Where does a ball screw come into play? Where does a rack and pinion come into play? the technology, there's not a lot to unpack there. I mean, we don't have an hour's worth of actual technology to talk about there. I mean, when you look at it, it's pretty straightforward. Ball bearing versus rack. It's
common sense stuff.
Yeah, it's pretty easy stuff. I mean, when you look at it, I know, Jesse, you guys do comparisons all the time here. We've talked about it.
Yep.
You'll welcome phone calls on this subject, correct?
Anytime, absolutely. If anyone's called ShopSabre, you guys know how we do this process. We put a lot of time into understanding your application, what you're doing with the machine. We put a lot of effort into getting to know you and what you're doing for sure.
You almost lost what you were going to say there, didn't
I
you?
did, yeah, absolutely, a little bit.
I could see it on your face.
I'm thinking rack, pinion, maintenance. Like, my mind is just swimming here.
Yeah, I saw it. I saw your eyes just really kind of look at me like, save me.
A little bit.
Yeah, it's okay.
Where were you?
I was watching you drown, man.
Oh,
that was
okay,
awesome.
sweet.
You did a great job, though.
Thank you.
You totally saved it.
Thank you.
But, yeah, in all seriousness, Jesse and I try to have fun with everything we do. I mean, even rack and pinion, versus ball screw, it's not a fun topic for most to talk about because it's confusing. There's a lot of information floating around there. And
You were reading from a dictionary half
I had
the time.
to read from a dictionary. I don't even like the dictionary.
Read that again. You should.
A ball screw is a mechanical linear actuator
Yeah,
that
stop.
translates.
Stop.
Yeah,
So much dictionary.
Yeah, I'm sorry. Did you almost fall asleep again?
A little bit.
Yeah. So, like I said, there is certain things with a ball screw that are going to be better than certain things with the rack and pinion, vice versa. There's certain applications where rack and pinion makes sense, where ball screw maybe does not. We hope that today you learned something. It's not meant to be boring. It's meant to be a little bit of fun. Reality is I can only cover so much in an episode with everything going on. And we hope we gave you enough to at least be dangerous. Right?
I would say so. I want to learn more about this underground CNC racing.
Yeah, we got to figure that out. Toretto. Yeah, so we got to figure that out. But like I said, guys, hopefully you got enough out of this. I know next week we're going to talk about plasma.
Yes,
So-
I'm excited for that.
Yeah, I'm excited about it too. I know we talk a lot about routers, and a lot of you probably are woodworkers, and probably that's great for you. But I know there's some metal workers out there. I know there's guys in fab shops that want to talk about plasma. We're hoping to roll in some plasma stuff here frequently. As we talked about rack and pinion, it's going to be rack and pinion
Right,
next week. We're going to talk
right.
about that. We're going to talk about plasma and how it works. Coming up
I'm
in
excited for the plasma.
Yeah, I'm excited too. A couple weeks we're going to have Router Bob on.
What?
Yeah,
He's going to
Router
make an appearance. Am I going to be on or am I off? You
I don't
kicking
know
me
yet.
off?
Rock, paper, scissors with Bob.
Ooh, I'll win that one every time.
But yeah, no, we'll probably have all three of us on with Router Bob here in a couple weeks. I know we
should be
got
a
a
lot of
couple.
fun.
Yeah, I'm excited about it. We have a couple interviews coming up too. We're gonna do a few interviews, so we're excited. We'll have some special guests coming in.
It sounds like we got the dates for the demo days too.
We do have the dates now.
you know what
July
those are?
13th. Yeah, July 13th, 14th, and 15th is going to be those dates. Again, contact the ShopSabre sales representatives, and they'll help get you qualified for attending that and getting you on the schedule. But we are going to start accepting registration for that probably in the next 2 weeks.
Cool.
So keep an eye on that. Keep an eye on our Facebook. If you haven't had a chance, make sure you like our Facebook, please. Go out and like our Instagram. I know Garrett really wants you to like Instagram and Facebook and say hi.
It makes them feel good.
Garrett, we're doing a contest coming up too, right? I mean, we have a contest. We're giving away. Do we want to say what it is yet? Do we want to say it? Garrett says yes. So
What is it?
It's a chessboard.
A chessboard?
Yeah,
like the one that Bob made in the
The
video?
one Bob made.
Oh, sweet.
So we got that coming up. So make sure you follow us because he'll have some instructions on what he wants to do there. It might be like post a video of you dancing on one foot and then
Let's get creative.
get some likes, something like that. But we're going to do something. It's going to be awesome. Like I said, hopefully you guys are having fun with us. We've been having a lot of fun here.
Well, Brandon, I'm having a lot of fun over here. It sounds like you're reading straight from the dictionary on your side.
Whoa, I'm not reading out. Yeah, I was
It
reading out
sounds
the
like
dictionary.
it.
Yeah, a little bit.
We all know you're the brains of this thing. I'm just here as your sidekick.
I don't know what that. We have a sidekick.
I
we already have the
appreciate-
sidekick.
Ooh.
The sidekick.
Oh, the machine. You got
Yeah,
me there.
I got you.
Good joke.
Yeah.
Good dad joke, Brandon.
Hey, thanks, man. Hey, I'm Brandon.
I'm Jesse.
Thanks for talking shop with ShopSabre.